Welcome to What's Up Kansas City. I'm James Webb. I'm the president of the Community of Reason. We have talks every Sunday at 1 o'clock at the UMKC campus. Today we have a guest that delighted us, Henry Frankel, who is a professor of philosophy in the UMKC philosophy department and one of the leading experts on the episode of the tectonic plate revolution. So,
well, I know before you asked me how I got interested in this whole idea, and as you know, the Continental Drift story, or the controversy over Continental Drift, which culminated in the plate tectonics revolution, is a wonderful example where we see competing theories that eventually one of them gets selected over the other. There's a triumph of one over the other, and it provided me with a really nice case study where I was able to read these papers and talk to many of the people who were involved in the controversy because they're still alive and wanted to talk about what they've done.
Perhaps we could go to the other end of the story and you tell us how you got from philosophy to an interest in geology and the rest of the story that it unfolded.
Yeah, sure. That's well, I began this by testing theories of continental growth and change. A lot of people have heard of Tom Kuhn, of course, the book on scientific revolutions, where he introduced the idea of scientific paradigms. And when I, in fact, went to graduate school in the 1960s, Kuhn's book had just come out in 1962, and I had a science background as an undergraduate, so I naturally drifted toward philosophy of science and this issue of scientific growth and change. And after Kuhn's book, there were other people who wrote about it, and Ray Lakatos, who was a Popper student, and finally somebody named Larry Loud, and they had these competing views about scientific growth and change. And after a few years while I was at UMKC, I had the chance to teach a course that was actually run by an old professor named Norman Royal, who was actually quite a force here at Kansas City, and actually when it was Kansas City University, and I taught a course, his course in physical science, and that's when I was first introduced to continental drift in the early 1970s. And so I used the continental drift story, learned enough of the history to use it as a way to test scientific theories of growth and change. And then quite frankly, I guess I got subducted, in a sense. I found the history so intriguing, and the earth science I was able to read. It doesn't take that much mathematical ability to read most of the original articles, so it was just natural for me to begin to look at this story. And then with a little bit of NSF funding and funding from the National Endowment for the Humanities, I got a chance to meet and interview, just like you are with me, I suppose, interview a lot of these earth scientists. So that's how I became interested in, and then it became really the sort of life project.
It was not your purpose today to talk to us about the origins of this, but if you could say briefly for some of our audience that's not deeply steeped in this, just about Wegener and the early drifters versus the stabilists.
Well, Alfred Wegener was the first major figure, or the first to offer a really highly developed theory of continental drift. There was an American geologist named Frank Taylor, who I believe in 1907 proposed the idea of continental drift. But it was really Wegener first in some articles in 1912, and then in a book in 1915, The Origin of Continents and Oceans, who presented evidence from many subfields in the earth sciences to argue that, in fact, the continents had changed their position relative to one another. And in his case, he claimed that the continents had all been together in a single landmass that he called Pangaea, or was called Pangaea. He actually didn't call it that, meaning, of course, all land. And then he argued that it eventually broke apart and the continents moved to their positions where we find them now. He believed that the continental drift actually, erroneously as it turned out, that continental drift had been a one-time occurrence, actually late in Earth's history, beginning in the Jurassic period. But that's not changed. We believe the continental drift is going forever and ever. Now, as far as the early debate went, most people did not believe in continental drift, and one good reason was that there was no known force or mechanism that made any sense that had sufficient force to propel the continents, and they thought, sort of plowing their way through the sea floor. And others argue that even if there were sufficient forces for the continents to plow their way through the seafloor, they wouldn't remain intact while doing it. They would break apart. In addition, there were alternative explanations, for example, about the formation of mountains, which were fixes. There was a famous American geologist named Dana, who in fact had this geosynclinal view that was a very popular view and did a good job in explaining the origins of mountains. For example, in North America, in Australia, in various parts of Europe, and that was pretty much the accepted view. And I guess I should add one other thing. There was this, Wegener noticed that, and many geologists had noticed this before, paleontologists, that there are areas now separated by vast oceans where you have similar life forms, or you had similar life forms if you look back at the history of life forms through the study of paleontology. But it turned out there was an alternative explanation for that. People postulated that there were land bridges, said that there had been a land bridge between Africa and South America, and then life forms were able to migrate or move from Africa to South America and vice versa, or to Antarctica, over these various land bridges. And the idea was that once there was no other evidence of migration of life forms from one continent to another, then, albeit somewhat mysteriously, the idea was put forth that the land bridges would disappear. So, you know, Wegener actually, well, that's enough to give you, I think, an idea about what the alternative view was, this fixist view. Another interesting thing I think about the earlier controversy before World War II is that you'll find that there was sort of a regional breakdown as far as the reception of continental drift went. And I do think it was actually independent, as one might think, of the world wars. Now, let me explain. It turns out that Wegener's theory of continental drift was more readily accepted in areas of the world where it did a better job in explaining the key geological problems. While fixism was the one that was favored by geologists in areas of the world where fixism did a better job. So, for example, in South Africa, where there probably was a stronger reception of continental drift than anywhere else, the reason is that Wegener offered a very good solution to what was called the problem of Permo-Carboniferous glaciation. During this time, there was good evidence that there were glaciers both in South Africa, Southern Africa, in parts of South America, in peninsular India, in Australia. Now, if you look at the separation now where these present land masses are, they're separated by these huge oceans. So what Wegener said was, he said, well, look, if the continents were put together as the way I propose, then we can have a rather large, but only an ice cap that we can say existed during this period over these regions, and then later these regions split apart and the individual, the fragments that are now our current continents drifted to their current position. So he offered, say, a nice explanation for this glaciation. Well, that was a major problem in South African geology. Well, and therefore, a lot of South African geologists thought Wegener's theory was very attractive. Another similar and related problem was the spread of this flora called Glossopteris flora that was associated, that actually is associated with the glaciation, and you had the same spread of areas that had lots of Glossopteris flora. So Wegener's solution to the origin of Glossopteris flora and the formation of this glaciation was nice. It did a good job explaining it, much better than fixism. And so you see not only people in those areas where the glaciation was prominent supporting continental drift, for example, again in peninsular India, but you also see specialists. So if you were a specialist in glaciation, then even if you were North American, there was a good chance that you at least were sympathetic to continental drift. Yeah.
Okay. You spoke mostly today about the episode where the paleomagnetism and the alternating bands of basically
seafloor material
of positive and negative polarization, and a zebra stripe pattern that was produced from the study of paleomagnetism. One thing about this to me is that the data was not gathered for the purpose of dealing with the issue of the of drift or not. And another interesting thing was, being an economist, this doesn't happen in economics, that people who were drastically opposed to the idea of continental drift, when they saw the evidence, accepted the drift doctrine. So maybe you could elaborate on that.
Okay. Well, there were two key developments after World War II. And one was this idea of paleomagnetism, first applied to continents. And it turns out that rocks retain, some rocks, become magnetized, and they retain their magnetization. And when they become magnetized, their magnetization is along the lines of the then existing geomagnetic field. Okay. Now, to backtrack just a tiny bit before we get to what we talked about today, there were these paleomagnetists who began working in the very late 1940s, really into the 1950s, and throughout the 1950s, and then on, but I'll talk about the 50s just for a moment. Now, and there you're absolutely right. The interest in paleomagnetism had nothing to do with continental drift whatsoever. In fact, it's kind of interesting that people became, basically physicists, became interested in this science of paleomagnetism, which studies the history of the Earth's magnetic field, because they were interested in the origin of the Earth's magnetic field. And so they rightfully realized that they could get a better understanding, perhaps, about the origin of the Earth's magnetic field if they learned about its history. And the two major people involved in this were, there was a man named Patrick Blackett, later Lord Blackett, who won a Nobel Prize for his work in cosmic ray research, and one of his students, Keith Runcorn. Both were physicists. They weren't geologists. Runcorn never took a course in geology, and I'm sure Blackett didn't take one either. But they heard this talk about paleomagnetism in the very late 1940s, 48, 49, and that's when they first heard about paleomagnetism, that there was such a field, and that's when they realized that they should start to study paleomagnetism. Now, and they eventually did. Runcorn got a job at Cambridge after he finished up his work as under the supervision of Blackett, first at the University of Manchester, and then Blackett started his own group of paleomagnetists, first at Manchester about 18 months after Runcorn had begun his, and then moved to Imperial College, where he took a job there and continued to work in paleomagnetism, or formed a group that did. And what they did was, so they ended up actually giving a very strong argument in support of continental drift. Okay, and this came to the fore say by 1959. A number of paleomagnetists, in particular a man named Ted Irving, who was part of Runcorn's group, and another named Ken Creer, had really strong evidence in favor of continental drift. Now, to our other story. The other story is about marine geology. And this is what really, really sold continental drift to most, to the physicists that had argued vehemently against continental drift. In particular, as you mentioned, there was this idea of seafloor spreading that was presented by a man named Harry Hess at Princeton University, and from that they developed sort of two corollaries. One was the Vine-Matthews hypothesis that explained these magnetic stripes on the seafloor that you have mentioned. The other one was called this idea of transform faults that was developed by Tuzo Wilson and another man named Alan Coode. And Wilson's idea of transform faults could only make sense if seafloor spreading were the case. And the same thing with Vine's explanation. They were both corollaries of seafloor spreading. Those views were confirmed in 1966, 1967. Yeah. And the interesting thing, when you talked about how it was accepted so quickly, was much of the data was actually developed by guys who were physicists. So they said, okay.
Yeah, the thing that impresses me about the outcome of this is that the people at Lamont Observatory at Columbia University, who were among the most opposed to drifting, were among the first to accept it once they saw the quality of the data. And that to me is a wonderful story about how science is supposed to work.
Yes, it is. There was some resistance by some of the people at Lamont, and they've been criticized for taking as long as they did, but as long as they did we're talking about 6-8 months before they finally said, I guess our data really does indicate continental drift. But it all did happen rather rapidly. Within just a few short years. Paleomagnetism was proposed in '63. Drift is accepted in the form of seafloor spreading in '66. Plate tectonics is invented in '67.
I think of economics, and the bat's going on for generations without any apparent their sort of resolution. There are sort of palace coups where they take over the discipline of the institutional apparatus, the discipline, and maintain a doctrine or revert to an older doctrine, which has happened recently. So I find this all very fascinating and to see this.
Well, the data in economics is not quite as clear cut, I take it, and it's easy to develop auxiliary hypotheses to continue defending your theory.
Thank you for watching What's Up, Kansas City. I want to thank the listeners for watching and viewers for watching, and thank our guest, Dr. Frankel, for being with us. And I'd like to say, in the spirit of the community of reason, that reason is not something that's easily accomplished. It's acquired.
Indeed it is. Thank you, by the way, too.